All right, guys, this is going to be the answer key to homework number 4. You're supposed to go through it or watch it, go through it together, and then also, if you have any questions, ask that on our Google Classroom, and we will answer it together. So, it says write the long way and the abbreviated way for all electron configurations. So the abbreviated way is just also another way of saying the noble gas notation, or the shorthand form, longhand form, right? We go through the whole, each orbital and energy level. Noble gas notation, or the abbreviated way, we pick a noble gas that is closest to but behind our element, and that kind of covers the electron configuration up to that point. And then we count, start from the next energy level and then just count until you get to your element. So why don't we do that? For this, you're going to need your diagonal rule worksheet and then also a periodic table, and that should be enough. It says, did you read the directions above? Nice job, we did. Smiley face, okay. Then write the electron configuration for nitrogen in nitrogen -3 ion. How many electrons are in the valence energy level? Okay, so nitrogen, first things first, periodic table. See, nitrogen, 7 protons, which means if it's neutral, it has 7 electrons. And we just go through until we fill up our orbital until we get to 7 electrons. So 1s2, 2s2, and that's going to be 4, and then 2p3, 2p3, right? 2, 2, 3, 7. Okay. Then the abbreviated way, right? So for this one, I'm going to pick a noble gas that is closest to nitrogen, but before it, not after it. So for this case, it's going to be helium, because neon is going to be ahead of it. It's going to be a little bit of a trick right here later, you'll see. All right. So it has the same configuration of helium, right, up until after that point. So that only really covers the first energy level, so 1s, right? So once we start here, we're going to start at 2s, 2s2, right? That's going to get filled in, and then we get to 2p, and then how many do we need to get there? 1, 2, 3. That's 3. Okay, and then, well, how many valence electron does it have? We can just look at our energy level here. So the highest one is 2, and in that energy level we have 2 and 3, so 5 valence. And then another way you can check that is look at your periodic table. Remember, from left to right, these have 8, these have 1, and we go 1, 2, skip over, 3, 4, 5. 5 valence, so it works out. All right, this is going to be, it's good, not too confusing, a little bit tricky once we get to this part right here for nitrogen -3, but how do we do that? So -3 means it has 3 extra electrons, right? Because the -3, each electron accounts for -1, so -3 means we have 3 extra from its neutral form. So it's going to be the same configuration as up here, we just have 3 extra at the end. So 1s2, 2s2, 2p6. All right. So now it gets a little bit funky here. So remember, for the short way, you want to pick a noble gas that's, well, closest to your element that you're looking at, but not going over. But for this one, if you notice, we have 2, another 2, 4, and then 6 means 10. So this N-3 actually has the same electron configuration as neon. So that would just be our answer right there. That would be it, just Ne. And you wouldn't have to put anything else. So what that is saying is N-3, you can account for its entire electron configuration with the electron configuration of neon. All right. Which neutral atom is isoelectronic with N-3? There's kind of some redundancy in this worksheet, but neon. Okay. Oh, and then I'll also put how many electrons are in the valence energy level? Well, for this one, if it's the same as neon, in neon, remember noble gas, that's going to be 8 valence. Okay, how many valence electron does a neutral nitrogen have? It's the same as up here, right? We already found that. 5 valence. That's it for the first one. Okay, next it says, write the electron configuration for chlorine and chlorine -1. How many electrons are in the valence energy level? So chlorine, right here, 17 protons, meaning we have 17 electrons. Why don't we just go through, so, right? And really, it's going to be the same up to that point, but 1s2, 2s2, 2p6. Remember, I want to get to 17, so right now I'm at 10. 3s2, 12. And now we get to 3p. So for that, we should just need to add 5 more. Okay. Also keep in mind, right, chlorine, not a transition metal, so we're not going to be doing any funky switching of our electrons there. And that's it for that. Okay, now I got to do the noble gas notation. So for chlorine, your first instinct might be like, oh, argon, it's right there, but that's not going to work. That's 1 over. So for this one, we have to do neon. Okay, and that's going to take us, well, chlorine is in the 3rd row, so we're going to start with 3s, because 3s starts the 3rd row, right there. So 3s, remember this accounts for 10, okay, so we're at this point right here, and then 3p5, all right? And then if you want to see how many valence, well, 3rd energy level here, 2 plus 5, so 7 valence. We have to write this down here again anyways. All right. Okay, so now, -1, chlorine -1 ion. Again, it's going to be the same thing as this, but now we have one more at the end here. Because remember, -1, we have an extra. 1s2, 2s2, 2p6, 3s2, 3p6. And like the last one, there's a little bit of a trick here. So chlorine, if we added 1 extra electron, it's going to have the same electron configuration as argon, Ar. And that's all you would need to write. Oh, we also have to do our valence, but it looks like we're doing a lot of noble gases here, so. And again, right, these are all 8. That's good. Next, it says write the electron configuration for, what is that, strontium. Okay, and then strontium -2. Strontium 38, get some bigger numbers. That's the neutral one, so we have 38 electrons. I'll just keep on 1s2, 2s2, 2p6, 3s2. I get to 38, and I mean not close, but just keeping track. 3p6, 4s2. Okay, let's see. So 2, 4, 6, 12, 18, 20. So once we get to here, 3D, we can fill that all in. It should be 30, so 4p6. Yeah, and then 5s2. All right, how many valence? The highest energy level here is 5. We just have 2, so 2 valence. I know I'm also supposed to do the noble gas notation for that one, but that one is not going to take very long because, let's see, strontium is right here. Okay, so our next closest noble gas is going to be krypton. We're just going to do bracket Kr, and then 5s, fifth row starts right there, and it's just going to get 2 till we get to strontium, so 5s2. Okay. Next, we have strontium plus 2. Plus 2 means we have 2 less, so we have 2 less here, so it's going to be the same thing. 1s2, 2s2, 2p6. And you're just doing these really helps you memorize it. 3p6, 4s2, 3d10, and then 4p6. Right, because we're not going to have that, right? Because it's a plus 2, so we lost those. And then for that, if we lose 2, right, so those are gone, we're just going to be left with krypton. That is just bracket KR. All right, and if you look here, 4, and, well, there's a 4 and 4 there, and we have a 2 and a 6, so we have 8 valence. All right, I hope you can kind of see the pattern that is happening here. I spelled krypton, I don't want to spell that wrong. Superman would be upset. Or maybe, no, he'd be happy that I did. And then how many does the neutral one have? That's just 2. It's also 2 because it's in this row, but you could also count because our 5th energy level just has 2, so 2 valence. All right, one more. Manganese. It's one of the weirdest Pokemon out there, too. Or was that, I don't know, maybe that's one of the evolutions of Mankey or something. So let's see, 25 electrons. Let's start until we get to 25. 1s2, 2s2, 2p6, 3s2, 3p6, and we're going to have, what is it, 25? 4s2 gets us to 20, and then 3d5. That's the 25. Don't need to do anything funky because we do have a full row here, and then a half full. So that is actually, this is stable. It's happy. For the noble gas notation of this, so our closest noble gas without going over is going to be argon. Okay, and that is going to account for everything up until the 4th row. So we have to start here, 4s, 4s2, 3d5. Highest energy level is going to be 2, so 2 valence. Okay, definitely is a little funky with the transition metals, but that's a good enough answer. That is a fair enough answer. Most likely it would be 2. Okay, here we have plus 4, so 4 is taken out. 4 electrons are gone for this one. All right, so it's going to be the same thing, but we don't have 4 here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. All right, so it's going to be the same thing for a noble gas. 4s2, 3d1. It's not going to be more stable if we take any one over here and bring it over here. So that is correct. Which neutral atom is isoelectronic with manganese plus 4? That is going to be 1, 2, 3, 4. Scandium. All right. How many valence electron does a neutral manganese have? It's going to be 2. I mean, there's different combinations in terms of your ions and everything, but 2 would be the best answer.